discuss the exponential smoothing. So in this video we are going to talk about exponential smoothing method. So in classification, demand forecasting method, you have two major classification. One is quantitative forecasting method, qualitative forecasting method. So in quantitative forecasting method, in this video we are going to see exponential smoothing. So coming to the concept of exponential smoothing. So exponential smoothing in general, it is used to estimate the demand forecasting for short-term demand forecast. Right? This comes under time series. So exponential smoothing is a technique used to detect the significant changes in the data by considering the most recent data. So most recent data we are taking and we are estimating the forecast. So therefore this method is used for making short-term forecast. So coming to the equation for estimating exponential smoothing is ft-1 alpha into dt-1 ft-1. So here one thing we need to understand, what is the difference between ft and t-1. ft means current period, t-1 means previous period. For example, ft means current month is July 2022. So t means July 2022, t-1 means June 2022. So this is the way we need to consider. Okay. So here ft, it is the final forecast after adding the smoothing constant here. Here ft1 is previous period forecast, dt-1 means previous period demand, and alpha is the smoothing constant. Normally this value it will be taken as a 0 to 1, any value. The forecast produced using this method are more accurate and reliable, and they predict for next period. The forecast shows projected demand and actual demand. So here what we are doing is dt minus f, demand minus forecast. This is called error. Already we discussed in previous methods. So error, it is multiplied with the smoothing constant and it will be added with the previous forecast. So finally we are getting this. Right, therefore one period from the future, so this forecast, it will give very good accuracy. So coming to this point, the smoothing constant put on each observation decreases exponentially. Normally it will decrease exponentially over the period of time. So that means the most recent observation has the highest weight. Recent one, we will get the highest weight. So older value, you will get the lowest weight we need to account while going for calculation. So this is often better than the moving average, simple moving and double moving average model that allocate the same weight. So here we are considering equal weight, just average, making average for 3 period or 4 period we are estimating. But this one we are adding the smoothing constant. We are taking the just previous period forecast and the previous period demand. So therefore when compared to simple moving average and double moving average, this forecast it will have more accuracy. Provided it is best suitable for estimating the next period. Here they are clearly given predict for next period. So coming to the other features of exponential smoothing, it is easy to learn and apply. So forecast, we are considering more recent period values like forecast or demand, whatever it may be. And second one, the actual value, that time period. So actual value for the time period. So this is another one. And we are using the value for smoothing constant. So 0 to 1 we are using recent value, we are adding more weightage, and old value we are giving less voltage. So this is what the work we are doing. Therefore this calculation is very simple, and it produces accurate forecast. The reason for accuracy means we are considered the difference between the actual projection and what actually occurred. So what is called error, we are multiplying with the smoothing constant, and that will be added with previous period forecast. This is the way we are doing. So therefore it gives very good accuracy. And point 3, it gives more significance to recent observation. So more significant to recent observation. So old observation accounting here, the accuracy of the forecast, it will come down. So fourth point, it produced forecast that lag behind the actual trend. So while estimating the demand forecasting in industry, they consider the trend as a major thing. Because if you are not updated with the trend, then your product, it may be out of market. So therefore this particular method, we have a bigger limitation is so only we are doing smoothing, but trend it is not accounted. So further discussion it is available here. It cannot handle the trends well. So exponential smoothing, it is best used for forecast short term and in the absence of seasonal or cyclic variation. So seasonal or cyclic variation, so this kind of demand pattern, it will not work. So as a result, forecast aren't accurate when data with the cyclical and seasonal variations are present. So therefore, this method is suitable for only the horizontal demand pattern. That means horizontal demand pattern means, for example, weekly demand pattern. So each day within the week, the demand value we will get little ups and downs. But overall, if you look at the weekly demand, it will be constant. So finally, from the simple exponential thing to some of the summary we are discussing, this will be used for short-term forecast. Here we are using smoothing constant. Here we are using only previous period forecast, previous period demand. So therefore, demand forecast for only one period, that is predict the next period, that will give more accuracy. And here they are clearly telling observation decreases exponentially. The most recent observation has the highest weight. And here the positive, easy to calculate and accuracy for only one period forecast, everything is good. But the problem is it is not considering the trend. So therefore any seasonal and cyclical variation in the demand pattern, that will not capture, that will give more error. So that is the limitation of this exponential smoothing. Look at this problem. A firm uses simple exponential smoothing with the smoothing constant alpha equal to 0.2 to forecast the demand. The forecast for the first week of January was 400 units, whereas the actual demand turned out to be 450 units. They are asking two things. One is the forecast demand for the second week of January, and the second requirement is assume that demand during the second week of January turned out to be 460 units. Forecast the demand up to February 3rd week, assuming the subsequent demand as 465, 434, 420, 498, 460 unit. So here first we need to understand the problem carefully. First step they are asking second forecast for the demand forecast for second week of January. So for that they are giving the first week of January forecast, they are giving 400 and the actual demand 450 they given. So what is the equation for the demand forecasting exponential smoothing? Ft equal to Ft minus 1 plus alpha into dt minus 1 minus Ft minus 1. So this is the equation. So already we discussed in the theory. So here what they are asking, subdivision 1, they are asking the forecast for January second week equal to, so forecast for January first week plus alpha 0.2 given, so alpha equal to 0.2. So first week of forecast, so plus alpha 0.2, demand for the previous period, so actual demand turned out to be 450. So 450 minus, what is the here again, the first week, Jan first week. Right, second step, here they are asking Ft. So Ft means January to forecast. So F January, what is the forecast for F January? So the first week, the forecast for the January first week is 400 unit plus smoothing constant 0.2. So 450 already we written. The forecast for first week is 400. Ft equal to 400 plus 0.2 into 450 minus 400, it is 50. Finally you will get Ft equal to 400 here 400 plus 10. So Ft equal to 410 units. Yeah, now we completed the first part, that is forecast demand for the second week of January. So now we are going to the subdivision B. For solving subdivision B, we are going to draw the table. We are going to draw the table here. So here we are going to write the week. Second one, demand. This one, it is called dt minus 1, and forecast. So this is ft minus 1, and here the forecast error, that is dt minus 1 minus ft minus 1, and here alpha into error. So this value we are going to refill, and finally forecast. So here it is called ft. So already we have an equation. So ft minus 1. So here we are writing ft minus 1, t minus 1, dt minus 1 demand, ft minus 1 forecast, the forecast error, this minus this, and error. So we are going to multiply. As per our problem, it is given alpha equal to 0.2. We are going to multiply with 0.2. Finally, we have a forecast error. So now what we are going to fill the week first. First it is started with Jan first week. So same January second week, third week, fourth week. Next February first week, second week, third week. So here demand for the January first week, it is given in the problem. First week of demand turned out to be 450 units. 450. The second demand forecasting for second week, it is given demand, the forecast the demand up to 460 unit. Second one 460 unit. Second week demand also given. Third week demand, it is given here. So it is started here 465. So then 434, 420, 498, and 462. So 462. So now we filled the data given here. So here forecast for the January first week. Already given in our problem. Forecast is the forecast for the first week 400 already given, and so here 450 minus 400 demand error, dt minus 1, ft minus 1, what is called forecast error. 450 minus 400, here it is 50. Then if you are multiplying with 0.2, so 0.2 into 50, here you will get 10. So finally forecast value, so you have an equation. So alpha ft minus 1 plus alpha into dt minus 1 minus ft minus 1. So you have an equation. So for this 410 already we worked out, 410 we got. So now forecast for the second period, what we are doing from this 460, we are going to write here. I think 410. So I am putting 410. 460 minus 410, again you have 50. So 0.2 into 50, again you will get 10. So finally 410 plus 10, here you will get 420. So next the previous forecast, you take it here 420. So here the difference is 45. If you are multiply with 0.2, you will get 9. Then final forecast you will get 429. So coming to this week, again the 429, you take it here 429. Here the difference is 29 plus 5, 334. 5 is difference. Multiplied with the 0.2, 1 you will get. So here 429 plus 1, 430. Next step, we are taking 430 here. Here you will get 420 minus 430. Here you look at that, you will get minus 10. So multiply with the 0.2, you will get minus 2, and you will get 438 minus 2, 428.
Again you will take 428 here. Here you will get 70. So 428 plus 70, 498. So multiply with 0.14 you will get. So 442 is the forecast. So finally you take 442 here. And forecast error is 20, 42, 62, 20. Multiplied with 0.2 you will get 4. Here you will get 446. So this is the demand forecast. This is the way you need to solve the problem. Now you have a forecast for everything. So here what we are doing is the previous period forecast we are taking. So first estimating for first period forecast, we are taking input for second week. Again third 420, here we used 429, here we used 430, 428, 442. So here we are just using the previous period forecast. That is the reason why this demand forecast is well suited for if you go for short term forecasting. So just one period if you want to estimate the forecast, this method it will give a very good accuracy. So thanks for watching.